Got you.
Okay, thank you.
All right, so here we go. We kind of already talked a little bit about this, but I just want to get this finished up, make sure we got this down. So if I said I, what did we say the value of I was equal to?
Square root of -1.
Perfect, square root of -1. What did we say I squared was equivalent to then? Forrest, I didn't hear you if you said.
-1.
Yes, it's -1. If you can't remember that, how do you get from I to I squared? You just squared it, right? So how do I get from here to what it's going to be here? So you got to square both sides, right? To be fair. What
By the
happens
way,
to square?
your screen isn't shared.
Say that again.
Your screen isn't shared.
Perfect. So the square and the square root cancel out, and then we end up with -1 being our thing. This is stuff that we've already talked about. What is I to the third then?
Square root of -1.
1.
All right, well, let's talk about this because none of those are correct yet, but let's talk about it. If I said x squared times x to the third, what does that equal?
X to the 5th.
Good. What did you do with those two?
I added the exponents.
Perfect. Now, here's what I need you to see, Kelly. This is what I don't think we do a great job as math teachers doing. Do you see how I went from here to here? Well, if I can go from here to here with this equal sign, I can also go backwards. So what if I gave you x to the 5th? What could you write it as?
X squared times x cubed.
What else could you write it as?
To the 1st and to the 4th.
Sure. What else could you write it as? Right? What are you making sure only happens? When you add these two, what do I have to add it up to?
5.
So, I mean, there's an infinite amount of ways that I can do this. Does that make sense?
Yeah.
Now, we want to do it the easiest way because we want to try to make it easy on ourselves. So how could I rewrite I to the third? What could that be the same as?
I2 and I.
And what is I2 really equivalent to?
-1.
And what is I really equal to?
Square root of -1.
So what is I to the third really equivalent to?
Negative square root of -1.
Perfect. Is that making sense? Those of you who are not talking, I'm telling you right now, those who are talking are this is going to stick with them a lot more. Even if you say it wrong, I'd rather you say it because then we can fix it. Now, what is I to the 4th going to be? Eric, you with me? Dominic, you there? Like I said, I'm recording this because, you know, maybe when I have a parent-teacher conference and parents want to know why, and I call you out and you're not able to answer, then I'm going to be able to say, hey.
I was going to say it was 1.
Well, Dominic, let's talk about this. I want to rewrite I to the 4th. Did you see what I did with the x squared and that stuff?
Yeah.
Did that make sense to you?
Yeah.
So how could I rewrite I to the 4th?
I squared times I squared.
Perfect. Why did you choose I squared times I squared? Why did you use the squared one?
Because it's easier.
Yeah, heck yeah. I want to use this one because what does that really equal?
I squared is -1.
So then I can write -1 times -1, and what's -1 times -1 turn into?
1.
So I is equivalent to the square root of -1. I squared is equivalent to -1. I cubed is equivalent to negative square root of -1. By the way, notice these negatives do not cancel out. Please make sure you understand that. That negative and that negative do not cancel out like normal. Right? When you see a negative right next to a negative, they normally cancel out. This negative does not. I to the 4th equals 1. Those are the 4 you really need to memorize. because all the other i's to whatever power are some version of this. Meaning like this, I to the 5th. Still using the same concept, and Dominic, still using your idea. Let's use the easiest one. How could I rewrite I to the 5th? Anyone can answer.
1
I
and
4.
4.
9.
I to the 4th times what?
I.
I to just the 1st, yes?
Yeah.
Destiny, does that make sense?
Yes.
Now, why did I want to use I to the 4th as many times as I can?
Because it's more simple.
It's super simple. And anytime I multiply anything times 1, what's it turn to?
1.
No.
Self.
Yes, itself. So this turns to 1. 1 times I to the 1st really just says that I to the 5th is the same thing as I to the 1st. And we know I to the 1st is square root of negative 1. So I to the 5th is the same thing as square root of negative 1. Do you follow me?
Yep.
So what is I to the 7th going to be equivalent to? Well, again, what do I need to use the most of as much as I can?
4.
So I'm going to go I to the 4th times, Daniel, what?
5.
Daniel. I to the 4th times I to the... Maybe your mic's not working, Daniel. I can't hear you, bud, if you're talking. Yeah, it's not working. Sierra? Jonah? All right, anyone? I to the 4th times I to the
3rd.
3rd.
3rd. Good. And then what does this really turn to?
1.
1. And then 1 times I to the 3rd is really I to the 3rd. So really I to the 7th is equivalent to negative square root of negative 1. Do you guys see yet the pattern that this is just going to keep repeating over and over again?
Yeah, it resets.
Now, let's talk about a little bit higher one. Some of you who are not seeing it yet, hopefully will start to see it. What if I wanted I to the 17th power? Annabella,
Yes.
how many I to the 4th? Like how many? So rewrite this using, like we said, I to the 4th. So I would write I to the 4th, then what?
Times I. 13?
Except I don't know what I to the 13th is. I want to keep using all the combos of this. So keep using I to the 4th as many times as you can. That's what I meant by that. Use I to the 4th as many times as you can.
So I to the 4th again.
Yep.
And then just an I.
No. Keep using I to the 4th. How many I's does this take care of, Annabella?
1.
No. When I say I to the 4th, that counts I's. That's I times I times I times I. That's 4 I's that I've used. Are you following me now?
Yeah. So you do
How many I's
another
am I supposed to be using total in this?
17.
So right now, how many have I taken care of if you look at all the I's that you have made?
12.
So can I use another 4?
Yeah.
And what does that get me to?
16.
Can I use another 4?
No.
Because that would get me to what?
20.
And I only have?
17.
So then how many are left over?
If you use another 4, then 3 will be left over.
No. I can only use 17.
Oh, 1.
So I've taken 4, 8, 12, 16. That takes care of 16 of the i's. So I need one more to get to the 17th. You with me?
Yes.
What does all of this turn to?
I-17
No,
or I-16.
no.
1.
What does I to the 4th turn to?
1.
What's this turn to?
1.
What's this turn to?
1.
What's this turn to?
1.
What's 1 times 1 times 1 times 1?
1.
What does all this turn to?
1.
And what's 1 times I to the 1st?
Negative. Squared negative or
It's just I. 1 times I is just I. And I is the square root of -1. Does that make sense, Annabella?
mm-hmm.
So someone help me out. You're good, Annabella. Help me out. How could I do this? Because if I had I to the 271st, I do not want to go, okay, I to the 4th, that's 4. That's 8. That's 12. That's 16. That's 20. That's 24. Like, I don't want to keep doing that. That's going to take forever. What am I really doing up here? What did I really do? Whoops. What did I really do up here?
You added up until you got to 17.
What is repeated addition, Kelly?
Multiplication.
So what could I do instead? Because I want to see how many I to the
Divide
4s I can.
Divide it.
So if I take 200, or let's do the easy one. If I take 17 and divide it by 4, I get 4, but what?
With a remainder of 1.
And isn't that remainder 1 I to the 1st? Why I knew that it was going to be to the 1st power?
Yep.
If I did I to the 18th, again, I would do 18 divided by 4 would give me 4, but it would be remainder 2. What does that mean? I to the 18th is going to be equivalent to I to the 2nd, which is -1. Is this making sense or what's going on? Let me know.
It makes sense.
Anyone having troubles? This is your chance to ask a question. This is actually it's a process called mods, and what it is we are not caring about how many times something goes into it. We are actually caring more about the remainder. So here's what I mean by that. If I said I wanted I to the 271st, what I'm going to actually do in my calculator, which you guys can have and use, and I encourage you to use them, is you're going to take 271 and divide it by what?
4.
4.
And when you do that, you take 271, divide it by 4, you're going to get 67.75. That means that 4 goes into 271 how many times without going over?
67.
67.
So I take 4 and times it by 67, that gets me to 268. What does that mean I have a remainder of?
3.
Does everyone understand how we got a remainder of 3? When I subtract this number and this number, I get remainder 3, which tells me this is going to be equivalent to I to the 3rd, which is negative square root of -1. Try this one on your own. By the way, whenever I am dividing by 4, what are my only remainders that I could have left? When I divide by
2
4,
or 3.
what are the only remainders that I could have?
1, 2, or 3.
1, 2, 3.
Yeah, you're missing one.
0.
Right, well, remainder 1, remainder 2, remainder 3, or we could actually have remainder 0, which means it goes into it perfectly without going over, correct?
Yeah.
That's right.
What's I to the 4th? How many times does 4 go into 4?
Once.
So what is I to the 4th going to be equivalent to? The one that has a 0 remainder. Does that kind of make sense to you?
Yeah.
That makes sense.
So if I asked you, here's something I want you to try. Try these. These should be quick and easy examples that you should love these on the test. They should be your favorite. Find out what those are equivalent to quickly on your own. Anybody get an answer for the first one?
I just got 1.
What'd you get?
1.
Good, because when I do this, 216 divided by 4 is 54. No remainder. That means that that's equivalent to I to the 4th, which is also known as 1. Yes or no?
Yep.
Yeah.
85. What'd you guys get it for an answer there?
Square root of -1.
When you do this, you get 21.25. If you take 4 and times it by 21, you'll get to 84, which should hopefully tell you that you have a remainder 1, which is a square root of -1. Now there's another way to do this, where you don't have to multiply the 21 times the 4. You can just look at the decimal, right? What if there's a remainder 1? That means if you think about back when we were in like elementary school, if you said, how many times does 4 go into 5? You used to go, it goes into it once, 4, 1 left over. And when you're in real baby school, they went remainder 1. And then you got to like a little bit higher level, like 5th grade. They said, hey, you take that remainder and you divide it by the 4. And that's how you get your real answer when you're a little older, which is 1 1/4. And if you think about that, how do you change that to a decimal? You take the 1, you divide it by 4, it turns into a 0.25. So if I get an answer and it's 21.25, what do I know what do I know the remainder was?
1.
Right, that's got to be a remainder 1. If I got an answer of 21.5, what do I know? Because of the 0.5, what do I know my remainder had to be?
1.
No?
2.
Why? Remember, 0.5 would mean that there was 2 divided by 5, which when I take 2 and divide it by 5, that's how I get that decimal. Are you guys understanding what I'm talking about here?
Yeah.
What would be the other decimal? What other one could you come up with? 21.75,
75.
which would be remainder 3. Or you would end up with just a 21. which would mean there was no remainder, which means it's equivalent to I4. This is I1, I2, I3, no remainder, I4. Yes or no?
Yep.
Questions before I move on, because that's it for I's. I'm legit on the test, probably on the ACT, SAT, they're going to just put I to the 275th. What is that equivalent to? And you're going to have to pick that answer. Good, Jonah. I appreciate your participation. I see you in the comments, buddy. I'm going to encourage you guys to try to get mics because it's so much easier to communicate. Like, can you imagine if I had to transcribe all the stuff that I was going to tell you into sentences and you try to understand that? It's going to be very hard. A mic is going to be vital to this classroom. So please get a mic. And I want this to feel like, I understand we're not physically here together, but it should be just like my classroom where you can just pop on. I do a cattle call kind of thing. I just have you guys answer, call out. If we talk over each other, it's okay. I'd rather have that because I like the participation than just sitting there in silence. So getting a mic, participating is going to be huge. I'm excited to grade Robert and Kelly. I'm excited to grade you guys' tests because I can see your participation, your effort. I know some of you from my other class, Orist, I know you work hard. So I want to see that from the majority of the class. That's what I'm looking for. And like I said, when I call you out and you don't say anything, there's no way for me to say that you aren't just logging on to this class and then just kind of walking away from the computer and just letting this thing roll. I know that that's definitely a thing that can happen. So when I call you out, the reason I'm asking that is because I'm trying to make sure you guys are staying there. Got to hold you accountable as much as I can. All right, so next thing, that was finished up 2.4. We are now moving on to 2.5. And we're going to talk about this thing called completing the square. I've already set you up for this because I've taught you how to do squares and square roots. Those of you who are in my class, I'm telling you I'd watch those videos about factoring because that's what this is going to have to do with. So if I ask you to do x squared minus 6x plus 9 equals 16. So some of you haven't been in my class. I try to relate things to stuff that's real life. And in football, when you're like just learning football, like I've taught my kid who was like 5 years old how to do football. I would tell him just to do one route. I'd tell him to run this way and then run like that. And that was like when they're, I guess 7, 8 years old. Well, when you get to high school, that same receiver is actually going to have options. That receiver can run this way, they can run this way, they can run this way, they can run all these different routes. It's called an option route. And the quarterback, QB, and this receiver have to read the defense. And so let's say that there's a defender standing right here, and there's not another defender on this side of the ball. This receiver is probably going to run what they call the out route. They're going to run here, they're going to run this way, because that makes this defender have to travel the farthest distance. Maybe there's a defender sitting right here, so that's why he's not running the out route. He's not running this route because I'd run right into him. This route, it's just easier to get. So if you want, this is the one that maximizes his potential for the QB to actually throw it to him and be open. The problem with this is it's the higher level class. The coach doesn't tell this receiver, okay, you just run straight and then turn a little bit. No, this receiver has to read the situation, the problem. They have to diagnose what's going on and they have to decide what route is going to be the best. You guys are like, what the heck is this guy talking about? I can't stand football. Sundays, I hate it because my dad only watched it, whatever. That's how Algebra 2 is. There's not a certain way to solve this problem. In fact, I'm going to show you 2 different ways. And sometimes there are better ways to solve it. Sometimes there's not. Sometimes they're both equally as good. But you have to start deciding when to solve these. Like when an engineer does this problem, this is part of a bigger problem. No one tells them which way to solve it. They know completing the square is a process that they can use to help this. They try completing the square. If it works, good. If it doesn't, okay, back to the drawing board. I got to try a different way to solve this. That's kind of how math is going to become. That's why if you ever watch, sometimes they sit there and look at math problems because they're trying to try different ways to solve it, and it doesn't always work. A lot of times kids get this confused because when we do math books, we make it to where the numbers work out nice and pretty and it's easy and that kind of stuff. But in real life, it's messy. It doesn't always work out. And so sometimes you got to try multiple things until you figure out the solution. Does any of that rambling make sense to you guys?
That makes sense.
So
Yeah.
one way that I can solve this is what I do is I look at this and I go, I have x's and x squareds. So at the beginning of my class, I told, hey, if we have two different types of x's, you cannot isolate this. We cannot get this to say x equals. It won't work because there's no x's that are going to cancel out that x. There's no x squared that's going to cancel out that x squared. So that means I can't isolate x. I can't get it alone. So I got an option to solve by factoring. And the way that we solve by factoring has got to be set equal to 0. So how can I set this equation equal to 0? Minus 16 to both sides. Does everybody understand that step?
Yeah.
Then the next thing is to factor. This says different signs. This says that I'm going to subtract. This says the bigger number's negative. So I know when I do my bubbles, one's going to be plus, one's going to be minus. I need two numbers that multiply to 7 but subtract to 6. Two numbers that multiply to 7 but subtract to 6 are 7 and 1, and the bigger number is with the negative, so I put the 1 here and the 7 here. And then what would make this bubble 0? Because if I take this bubble and I multiply it by this one, if this thing is a 0, I don't care what this is, it's all going to turn to a 0. So what makes the front bubble 0?
-1.
Good. What makes this bubble 0?
7.
So I actually have two answers for this question. If you put, in the original, if you put a -1 into this x, into this x, it's going to make this equation true. If you put in a 7 into this x and this x, it's also going to make this true. You use any other x's and that will not make that equation true. Does that make sense?
Yep.
Another way to solve this is to recognize that this is a perfect square right off the bat. And just with time, you're going to start recognizing perfect squares faster. But this number has to have a square root, which is x. This number has to have a square root. Oops, that's got to be a plus sign, which is a 3. When I multiply these two together and then double that number, that has to be the number that's sitting there, which 3 times x is 3x, doubled is 6x. I know this is a perfect square. And the way that you put that in its factor is x and 3, you square it, and whatever sign was here goes right there. Now the reason that that is helpful is I can square root this side and square root this side. I put the square root sign in. Why am I saying that? What do I have to put if I put the square root sign in?
Positive and negative.
What?
Positive and negative.
Yeah, plus or minus sign, and then square root of 16 is 4. And then that legit means there's going to be two answers. X minus 3 when I get a positive 4, and x minus 3 when I get a negative 4. And then you add 3 to both sides, and you get x equals 7, just like we did in the previous one. And add 3, you get x equals -1. Just like we did. Those are the same exact answers we got before. Two different ways of attacking that problem, both resulting in the same answer. Does that make sense?
Yep.
That makes sense. Yeah.
Anybody else?
What about
make
the
sense?
start of it though?
What do you mean?
Start. Like when
Say that
we
again?
started. Like, how'd you get to x minus 3? That's the only part that I was a little
All right,
confused.
do me a favor, okay? Because I know that you came from my other class, from another class. All of you that came from another class, I'm telling you this will be huge, especially since you understand the way that I talk. I need you to, over the next couple of days, watch the YouTube videos on my Martin's Math. Because we're going to be doing this the rest of the year, factoring. And so I refer to them. So under Martin's Math, you need to watch the first video I ever posted, which was factoring A equals 1. There's another one that says special cases. And then there's another video that says updated. A doesn't equal 1. Those are the 3 videos you need to watch over the next couple days, because this is how I factor. That's my YouTube is Martin's Math.
Okay, thank you.
I record every lesson, so if you're ever absent, it's recorded on there. Like I'm recording this class right now, and I'll post it up on YouTube, and you can watch if you're ever absent or anything like that, or you just need to watch it again, or if you need to fall asleep and you really just want a boring voice, you can put me on, and it helps kids fall asleep. Evidently, they do in class all the time. So, anyways. Does that make sense for this? So that will help you out, Robert, with the factoring. Look at the special cases, especially because that's where I factored it the way I did, and then maybe that will help you.
All right. So the special cases one, is that like specifically about they'll start?
Yep. Yep, okay. It is. And the reason I need you to watch them is because that's the way I'm going to teach factoring or talk about it, and it will make more sense if you understand the way I factor.
That's understandable. I appreciate that.
So watch these 3. They will help you too, I think. I have kids that come home and they're like, oh my gosh, from college, and they're like, man, that factoring stuff helps me out so much. The other kids still don't know how to factor. So I think it's a really good way. It's the best ways I've seen. Which kind of leads us into our next one. So maybe I'll just hold off on it because it talks about that perfect square thing that I just did. This idea of completing the square. So I guess I'll hold off on that and we'll really get into it tomorrow. But I can kind of start it. So perfect squares are a certain situation that happen there. That's why they're called special cases. And what happens is I'll give you a perfect square. How I know this is a perfect square is this has a square root. This has a square root. This is a plus sign. And this times this doubled is this middle number. That happens every time you have a special case called a perfect square. And what it factors to is x plus 3 squared. Notice this is where the x came from. The square root of this is where that came from. This sign is where that came from, and then you just square. Now, not all trinomials are perfect squares. It has to follow that pattern. So like x squared plus 25 plus 10x. You'll notice the way I built that, I went this number first, then I wrote this number, and then I made this number. Well, that's because in my head, I'm going, okay, I need to make a front number that has a square root. Well, that's x. I need to make a back number that has a square root. Well, that's 5. I need to make this a plus sign, and then I multiply these 2 and double it, and that's how I come up with my middle number. Does that make sense, Robert?
That cleared up everything. I appreciate that.
And then this is going to make my bubble become x plus 5 squared. Again, the square root, that's where these numbers come from, and the sign from here is what goes there. This says same sign, this says both. Robert, I really encourage you to still watch those videos though, because they're amazing on factoring. I think I might be a little biased, but I think that guy's phenomenal. Anyways. If I had 4x squared plus 16, here's how I get the middle number, right? I say, hey, what's the square root of that? 2x. What's the square root of that? 4. This times this is 8x. Double that is a 16. And here, I'll make a negative 16 here. So that's actually a perfect square. And that square root, the factor of that would be 2x minus 4.
Does it matter if the middle number is positive or negative?
All that does is change this sign.
Okay.
This tells me that they're both the same sign. If you watch that video, that will make more sense why I know this is same signs. But this means that they're both going to be either plus plus or minus minus. This tells me whether they are both positive positive or whether they're negative negative together. Like I said, watch those videos. It's going to clear everything up a lot more.
Okay, thank you.
All right, and then tomorrow we'll talk about this completing the square idea. All right.
You said we had homework tonight?
You will have homework. Yes, it will be